To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
So, my dear children, in the earlier chapter, we discussed all the theoretical things related to the hydrocarbons and the derivatives lesson part. Now it's time to discuss questions related to the lesson. So, first of all, we are going to start from the questions given in your textbook. So, you are given with the first question. LP gas is a mixture of propane and butane. Write the molecular formulae of propane and butane. So, propane, my dear children. Propane. So, as it is a N, that means it is an alkane. So, C3H 3 times 2 plus 2. C3H8. Next one, butane. So, C4H 4 times 2 plus 2. C4H10. Right? The molecular formula for propane and butane. Then the next one. Draw the structures of propane and butane. Draw the structures of propane and butane, my dear children. Let's see. Propane. 1, 2, 3. Then hydrogen. So, this is, my dear children, propane. Propane. Then the next one, butane. 1, 2, 3, 4 single bonds, then hydrogen. You know that each carbon atom can create 4 bonds. So, complete hydrogen like this, so that each carbon would have 4 bonds. Okay. So, this is butane. Propane and butane. Right, my dear children. LP gas is a mixture of propane and butane. So, if only carbon dioxide and water are formed during the combustion of the above compounds, write balanced chemical equation for their combustion separately. So, we'll take propane first. C3H8 going to react with oxygen to create carbon dioxide and water vapor H2O. So, let's balance this thing then, my dear children. So, here 3 carbon molecules. So, that means, my dear children, you have to put here 3. So, 3 carbon molecules now all together. Here you can observe, now here 8 hydrogen atoms. Okay, there are 8 hydrogen atoms over here. Here 3 carbon atoms. So, I have put 3 to here. Now, here there are 4 hydrogen atoms. That means we have to put over here 4. Actually, here 8 hydrogen atoms. So, 8 hydrogen atoms means over there we have to put, in order to make 8, we have to put 4 hydrogen, because altogether there are 4 times 2, 8 now. Okay. Right. Now, let's count the oxygen. 3 times 2, 6 plus 4. Altogether there are now 10. So, you have to put 5 over here. Right. You can put 5 over here. So, let's erase this thing. Here also. Then we'll put 5 oxygen gas. Right. Now, let's count. 3 carbon, 3 carbon, carbon balanced. Hydrogen 8, 4 times 2 hydrogen 8, balanced. 5 times 2, 10 oxygen. 3 times 2, 6 plus 4, 10. Correct. So this is for propane. Then let's go for butane. C4H10 plus oxygen gas creates carbon dioxide and water vapor. So the balancing. 4 carbon, you put 4 here. Now 10 hydrogen, then you put 5 here. Now my dear children, 4 times 2, 8, 5 times 1, 5. That means 8 plus 5, there is 13. Now there is a problem, right? If the oxygen count is an even number, then there is no problem. You can directly put the number in front of it by dividing from 2. Now the total oxygen count over here is an odd number, not an even number like in the previous. Then what do you have to do? Then my dear children, you can do this trick. What is that? So here the oxygen count should be equal to 13, no? Already, right, there is 2 over here. So if you put 13 to here, then 13 times 2, it becomes 26. But however, in order to make into 13, I'm going to use this thing. 13 over 2. So when you multiply 13 over 2 by 2, 2 to 2 is getting cancelled and 13 could be obtained. And over there at the right hand side also, 8 plus 5 becomes 13. When writing the balanced chemical equation, we can't use or we can't put these things as like this. There should be a whole number. So in order to convert these things into a whole number, you multiply each and every term by 2. By that way, we can cancel off the, right? By that way, my dear children, we can cancel off these 2. So you multiply each and every term by 2. So 2 times C4H10. When you multiply this one by 2, 2 to 2 is getting cancelled. It becomes 13 oxygen gas. Then here when you multiply this one by 2, 8 CO2. Then when you multiply this one by 2, 10 H2O. Now let's check whether it is balanced or not. 4 times 2, 8 carbon. 8 carbon, balanced. 2 times 10, 20 hydrogen. 10 times 2, 20 hydrogen. 13 times 2, 26 oxygen. 8 times 2, 16 plus 10, 26. Well balanced. Right then. So these are the two reactions, balanced chemical reactions for the combustion of butane and propane. Then the next one. Is the use of LP gas as a fuel more environment friendly than using firewood? Present your ideas. So the question is asking, is the use of LP gas as a fuel more environment friendly than using firewood? Present your ideas. No. Why is that? Because there are several reasons. Number one, LP gas is obtained from petroleum, or else we can say from fossil fuel. Which is not belong to the natural carbon cycle. right? Therefore, carbon dioxide which emits will directly impact the environment. Right, so this is the reason, my dear children. LP gas is obtained from fossil fuel, my dear children. You know that thing. So, which is not belong to the natural carbon cycle. It's not belong to the natural carbon cycle, right? So, that means this would take somewhat longer time, pretty much long time, like millions of years, right? So, actually fossil fuel is belong to the natural carbon cycle, but this would take like millions of years to make. So therefore, burning of fossil fuel is going to release carbon dioxide gas once again to the environment. However, that carbon dioxide has been planned to emit within like millions of years gradually. Suddenly we are now burning these things and release these things to the environment. So yeah, these carbon dioxide which is getting emitted by the burning of fossil fuel will create severe environmental problems. So this is the reason, my dear children. Okay, so LP gas is obtained from fossil fuel which is not belong to the natural carbon cycle. Therefore, carbon dioxide which emits will directly impact the environment. Okay, right. What would be, so octane is the most abundant alkane contained in petrol. What would be released if petrol completely burns in the combustion engine? Very simple, my dear children, CO2 and H2O. If complete combustion is going to occur, hydrogen will produce water vapor and carbon will produce carbon dioxide gas. Next one. State two unfavorable substances related to the environment released to the environment during the incomplete combustion of petrol. So if incomplete combustion is going to occur, definitely carbon particles will release. Okay, carbon particles. Then, my dear children, if there is less oxygen gas, then carbon monoxide will emit. So carbon particles and carbon monoxide, these things are two unfavorable substances. Right. Octane is the most abundant alkane contained in petrol. How do you know that LP gas burn incompletely in the gas cooker used at home? So if LP gas is going to burn incompletely, definitely the flame which is given out should not have a blue color. If the flame is giving out a blue color, my dear children, then we can say that it is showing a complete combustion. So if there is no blue color, then we won't be able to observe a complete combustion. So it's very simple. Blue color of the flame will turn into yellow or red. Right? So blue color of the flame will turn into yellow or red. This is how you could identify the incomplete combustion. Next one. So polythene is a commonly used artificial polymer. What is the chemical name for polythene? Very simple, my dear children. Polyethylene, right? Polyethylene. Polyethylene. Draw the structure of monomer that forms polythene and write its name. So the monomer is very simple. This is the monomer, which is the ethene molecule, right? So this is go by the formula C2H4, which is referred as ethene. Ethene, right? Ethene. So this is the structure, right? And the chemical formula for the ethene molecule. Then the next question. So state 2 advantages and 2 disadvantages of polythene. So first of all, we'll write advantages. Number 1, cheap. Number 2, easy to use. Easy to use. So these are advantages. Then disadvantages, right? So I'll use a different color one to write down the disadvantages then. Number 1, get collected in the environment. Right, get collected in the environment, because you know that these polythene substances are not biodegradable. Okay, then the next one, number 2, can cause or else consuming polythene will kill animals, right? So consuming polythene will kill animals. These two are disadvantages. Disadvantages, right? So get collected in the environment, that is a major disadvantage, and the other one is consuming polythene will kill animals. Okay, right. Give 3 reasons to support this statement. What statement? It is more suitable to use PVC pipes as water pipes rather than iron pipes. So rather than iron pipes, it's wise to use PVC. So you have to provide 3 supportive sentences for that. Number 1, long lasting. Long lasting. Number 2, cheap. Number 3, resistant to corrosion. Resistant to corrosion, right? So number 1 is PVC is long lasting. Number 2, it is very cheap. And the third one, it is resistant to corrosion. You know that iron has the ability to corrode, but however PVC is not, right? Next one, what is the name of the monomer that is used to make the polymer PVC? So what is the name of the monomer that is used to make the polymer PVC? So we know that PVC is created by the use of polyvinyl chloride. Polyvinyl chloride is the monomer which is being used. So this monomer is also referred as polychloroethene. Okay, not polychloroethene, chloroethene, right? Chloroethene is the one. So, polychloroethene is the polymer, my dear children. Chloroethene is the monomer which used to create the PVC. So, we can write the answer chloroethene. So, the name of the monomer used to make polymer PVC is chloroethene. Chloroethene. We'll write the chemical formula as well. C2H3Cl, chloroethene, right? Okay, then the next question. It is more suitable to use PVC pipes. So, we did that in the fourth question. Draw the structure of that monomer. So, we have to draw the structure of that monomer. So, here we go. C double bond C, chlorine, then all the others are hydrogen. This is that monomer. Name 3 natural polymers of your choice. DNA, starch, DNA, starch, proteins. Right? DNA, starch and protein, and also rubber is considered as a natural polymer. So, these are the natural polymers, my dear children. Right then. So, we have studied, we have answered all the questions related to the textbook. Right? Now, it's time to discuss several questions, several extra questions related to the lesson part, my dear children. Right then. So, let's see the extra questions. So, first of all, you are given with a question, hydrocarbon contains. So, in here you have to choose the most accurate answer. So, hydrocarbon contains carbon only, hydrogen only, carbon and hydrogen only, right? So, hydrocarbons contain carbon and hydrogen only. This is our answer. Next one. Alkane has single bonds between carbon-carbon atoms, double bonds between carbon-carbon atoms, triple bonds. So, as it is an alkane, it contains single bonds between carbon-carbon atoms. Single bonds between carbon-carbon atoms. Right then. Next question. Methane is a biogas. Correct. We discussed that methane is a biogas, right? A hydrocarbon. Once again correct. It is a hydrocarbon because it contains only carbon and hydrogen. An alkane. Once again correct. Ane, no. So, in the last, you can observe ane. So, if it is showing ane, then definitely you know that it contains an alkane. So, all of these things are correct. Next one. Number of carbon atoms in propene. So, no matter in no ane, they are asking about the number of carbon atoms, no. So, in propene, we can observe 3 carbon atoms, 3, right? In meth, 1, in eth, 2, in prop, 3, in but, 4, right? Then the next question. The main products created during the combustion of a hydrocarbon. Very simple, my dear children. Combustion of a hydrocarbon is going to create carbon dioxide gas and water vapor. So, carbon dioxide and water vapor. Yes. Carbon dioxide and water vapor. Then the next one. Common name for octane. Very simple, my dear children. Once again, petrol, right? This is the most abundant, right? Most abundant compound contained within petrol, right? Octane. So, that is why it is given as the octane, name as the octane, right? Then the next one. Anhydrous copper sulfate used to identify. So, we use anhydrous copper sulfate to identify water. Right? Anhydrous copper sulfate can be used to identify water, my dear children. Question number 8. chemical formula for tetrafluoroethene. Tetrafluoroethene. So tetrafluoroethene means, tetra means 4, fluoro, fluorine, then the ethene molecule. So C2F4. Here we go. C2F4 is the answer. Next one, use of Teflon. So Teflon is polytetrafluoroethene, which is used to make snowshoes and non-stick pans. Let's see. To make conduits, incorrect. To make gutters, incorrect. To make fertilizer, once again incorrect. To make non-stick pans, yes, this is our answer. Right? The use of Teflon is to make non-stick pans. Next one. Not a use of polychloroethene. Polychloroethene, that means PVC, not a use of PVC. To make gutters, to make insulations, to make snowshoes, to make garbage bins. So my dear children, not a use, no. To make garbage, to make snowshoes, we use Teflon. To make garbage bins, we use polychloroethene or else PVC. There are some garbage bins which are made by PVC. Okay. So our answer would be to make snowshoes, my dear children. To make snowshoes, we use Teflon. Okay. And this is the answer for the question number 10. Next one. Right. Question number 11 then. Polytetrafluoroethene. Polytetrafluoroethene. Fluoro, that means it contains fluorine, my dear children. Fluorine. Polytetrafluoroethene is also called as Teflon. Teflon. Right? Teflon. It's mentioning about fluorine. So polytetrafluoroethene, this is Teflon. Next one. Common name of polychloroethene. Common name of polychloroethene. Polychloroethene. Chloroethene. That means PVC, right? Yes, PVC. Polyvinyl chloride or polychloroethene. PVC. Next one. Monomer of natural rubber. Very simple, my dear children. The monomer of natural rubber is the molecule which is referred as isoprene, right? Isoprene. Isoprene. Isoprene is the molecule which is used to create natural rubber. Okay, so that is the monomer of natural rubber. And the next question. Example for natural polymers. Example for natural polymers. Rubber. Correct. Rubber is correct, right? DNA. Once again correct. Starch. Of course correct. Then all of these things are examples for natural polymers. Then the next one. Property of vulcanized rubber. Property of vulcanized rubber. High elasticity. Incorrect. Actually, in making vulcanized rubber, we are going to reduce the elasticity, right? Next one. Hard. Of course correct. Hardness. Ductile and brittle, once again incorrect, right? Okay, ductility can be observed in metals. Brittleness can be observed in usually non-metals like clay. Right, then the next one. Vulcanized rubber is an example for natural polymer, polymer with side chain, linear polymer, polymer with cross links. So we discussed that by the combustion of sulfur, right, or by the reaction of sulfur with linear chains of rubber, we are going to create vulcanized rubber which has not side chains but cross links, my dear children. Okay, so here we are going to create polymer with cross links through the vulcanization of rubber. Right then, question number 17. Select the component which is not organic. Select the component which is not organic. Starch, organic. Lipids, organic. Isoprene, once again organic, because all of these things are plant and animal based substances. However, my dear children, sodium carbonate is not considered as an organic substance as it is a carbonate. So, we discussed within the lesson part, carbonates, bicarbonates and oxides of carbon are not considered as organic. Okay. Right. Then the question number 18. What is the chemical that can be used to identify water vapor? Hydrocopper sulfate. Incorrect. We use anhydrous sulfate. Hydrocopper sulfate is already in blue color, so we won't be able to observe water from it. Next one. Anhydrous cobalt chloride. Of course, we can use this thing. I think you can remember within the first lesson of your grade 10 syllabus, right? We discussed how to identify water. So over there we used anhydrous cobalt chloride, my dear children. Right then. Question number 19. Disadvantage of artificial polymer. Durability. That's an advantage, no? Next one. May harm biodiversity. That's is a disadvantage, right? That is a disadvantage. It's going to harm the biodiversity. It will harm the biodiversity. So it is a disadvantage. High cost, no. Flexibility, once again, no, right? Next one. Figure shows the structure of. So this is very easy to identify, my dear children. Don't just look at the structure and decide whether what kind of a structure is this. Okay, just count the number of carbon. 1, 2, 3, 4. There are 4 carbon atoms. 4 means it should be but. Check what are the what is the or check what is the arrangement of bond, right? Or what are the types of bonds contained within carbon atoms. So all the bonds available in here are single bonds. That means it should be an alkane. So this is butane, my dear children. So go for the answer that contains butane. Over there is butane. So second one would be the answer. Butane is the answer because it contains 4 carbon atoms, my dear children. It contains 4 carbon atoms and all the carbon atoms are having single bonds. All the carbon atoms are having single bonds, right? If there are single bond between carbon atoms, then my dear children, it is an alkane. Okay, and the other thing is that there are 4 different carbon atoms, so therefore these things are, or this structure is a butane, right? This structure is going to reflect the butane structure, right, my dear children? Then the next question number 21. So the 21st question, example for a linear polymer. Example for a linear polymer. So linear polymer is a polymer, right, which do not have any cross links or side chains. According to a straight line, these polymers have been arranged. Now let's see. Polythene, yes, a linear polymer. PVC, once again, yes. Rubber, once again, yes. So all of these things are linear polymers, my dear children. So the answer would be above all. Next one. C5H10 is the chemical formula for C5H10. C5H10. So here carbon count is 5, hydrogen count is 10. That means almost 2 times, now exactly 2 times as the carbon atoms. So this should be an alkene, not alkane, okay? In order to be an alkane, it should be 2n plus 2. So my dear children, this is pent as there are 5 carbon atoms and ene. So go for the answer pentene. Pentene. Pentene is the answer, right? Why it is ene? Because the hydrogen count is twice as the carbon count, okay? Then the next one, question number 23. What is the most reactive among these molecules? Ethene, octane, ethine, methane. So my dear children, I think Can you remember we discussed about the reactivity of alkane, alkene and alkynes. Over there we discussed that single bonds are the least reactive ones. Double bonds are somewhat more reactive than single bonds. Triple bonds are the most reactive ones. So alkynes are the most reactive ones from these types of hydrocarbons. So go for the answer that contains alkyne, ethine. This is the most reactive molecule from these given. CH2 repeating units can be observed in. So CH2 repeating units, altogether C2H4 repeating units. C2H4 repeating units can be observed within, my dear children, polythene, right? Within polythene we can observe C2H4 repeating units. Right, then the next one. Small molecules contributing to form polymers are called, very simple my dear children, small molecules contributing to form polymers are referred to as monomers, right? These are the monomers. Small molecules contributing to form polymers are called as the monomers. Next one, artificial polymer, terylene, bakelite, PVC, all. So PVC, bakelite, terylene, all of these things are artificial polymers, my dear children. Under the classification, we even have studied these things under the artificial polymers. Okay, right then. The question number 27. During vulcanization, natural rubber is reacted with, very simple my dear children, natural rubber is reacted with sulfur to create crosslinks, right? To create crosslinks, natural rubber is reacted with sulfur, right? Natural rubber is reacted with sulfur to create crosslinks. So vulcanized rubber is created by using, okay, vulcanized rubber is created by using sulfur, okay, by using sulfur. By the reaction between natural rubber with sulfur, we can create vulcanized rubber. Then the next one, question number 28. Electrical insulator, polytetrafluoroethene, polythene, PVC, and above all, polytetrafluoroethene or else Teflon. Yes, it is an electrical insulator, polytetrafluoroethene. Next one, polyethylene or else polythene. Once again, yes. PVC, once again, yes. So all of these things are considered as electrical insulators. All of these things are electrical insulators, my dear children. Right. Select the correct answer. All compounds that contain carbon atoms are organic. Incorrect. All the things which contain carbon atoms are not considered as organic. Sodium carbonate is not organic, no. Carbon dioxide, not organic. Next one. There is some organic matter without carbon atoms. Once again incorrect. In order to be organic, it should definitely contain at least one carbon atom, right? Next one. Simplest organic matter is hydrocarbon. Now that is correct, my dear children. This should be the answer. Let's see the other one as well. In all fuel, there is carbon and hydrogen only. Incorrect. When we are discussing about the structures of firewood, we discussed that there is nitrogen and oxygen as well. So, incorrect. Next one. The incorrect answer. Polytetrafluoroethane is conducting heat. Polytetrafluoroethane is conducting heat. Correct. That is why we are making, right? That is why we are making, you know, like non-stick pans, non-stick cooking pans. Cooking pans, we are making cooking pans by using polytetrafluoroethane, no. So therefore, it is conducting, it should conduct heat. Otherwise, we won't be able to create cooking pans from it. Then the next one. Polyethylene can withstand tensions. Correct. No problem. Polyethylene or else polyethylene can withstand tensions. Next one. Polychloroethylene is also called as polyvinyl chloride. Correct. Next one. Polymerization of isoprene creates vulcanized rubber. Totally incorrect, because in order to create vulcanized rubber, right, we have to take natural rubber, which is polyisoprene, and we should combust it, or else we should react it with oxygen. We should react it with sulfur, not oxygen. Okay, we have to react that particular thing with sulfur, my dear children. In order to create vulcanized rubber, we have to react that particular natural rubber with sulfur. By that way only we can be able to create a vulcanized rubber. So this is the way of creating vulcanized rubber. It's not getting created naturally. Artificially we have to react it with sulfur. Okay, right then. So we have answered 30 MCQ questions, my dear children, right? So now it's time to discuss other types of questions. So the second main types of question, here you have to put a tick or else a cross. First one, ethene is not an organic substance. Totally incorrect, right? Ethene is an organic substance. Next one, DNA is a polymer. Correct. DNA is a good natural polymer. That is correct. Next one, rubber is made by polymerization of isoprene. That is also correct. By the polymerization of isoprene molecule, rubber is made. Correct. Teflon can withstand tensions. Teflon can withstand tensions. Incorrect. Actually, PVC and polythene can withstand tensions, right? Next one. Small molecules contributing to form polymers are monomers. Correct. Small molecules which are used to create polymers are referred to as monomers. That is correct. Next one. In a polymer, there are a large number of smaller units. Once again correct. In a polymer, there are a large number of smaller units. There is no problem in it. This is also correct. Next one. Alkyne is more reactive than ethene. Correct. As it is an ene. Ene means alkene. Ethene is an alkene. So therefore, alkyne is more reactive than ethene. Correct. No problem. Next one. Common formula for an alkene. See, alkene is CnH2n plus 2. Incorrect. Common formula for an alkene is CnH2n. Next one. Petrol is not a hydrocarbon. Incorrect. Petrol is a hydrocarbon. The most abundant hydrocarbon present in petrol is octane. Next one. Combustion of a fuel release carbon dioxide gas and H2O only. We won't be able to say that thing, because combustion of a fuel may release other gases too, like carbon monoxide, like unburned carbon particles and so on. Okay, so combustion of a fuel, carbon dioxide and water vapor are getting released, but however there can be other substances as well. So here the sentence is saying these are going to release carbon dioxide and water vapor only. So therefore it is incorrect. Next one. Combustion of artificial polymers release poisonous gases. Correct. This is correct. Next one. Rubber is a natural polymer. That is also correct, right? That is also correct. No problem. We know that rubber is a natural polymer. No problem. So these are the answers for the second question then, my dear children. Right? Now let's head on to see the next type of question. In this one, you have to write down the correct answer. So write the three main types of hydrocarbons with the common formula. Three main types: alkane, Common formula CN H2N plus 2. Alkene CN H2N. Then alkyne, my dear children. Alkyne goes by the common formula CN H2N minus 2. Okay, this is the common formula for alkyne. CN H2N minus 2. Okay, right. Draw and show the polymerization of polythene. Okay, polymerization of polythene. First of all, ethene, the monomer. Then it breaks the double bond over here to create the repeating unit like this. The repeating unit. Okay. Then finally, my dear children, large number of these units, like n number of these units, join to create the polymer. So this is the polymer, right? So this is the monomer, which is ethene C2H4. This is the repeating unit. This is the polymer, polythene. Right. So the monomer ethene molecule goes by the formula C2H4. This is the repeating unit which is created after breaking down of the double bond. This is the polymer which is polythene, right? Which is polythene, which is created by the collection of large number of these kinds of repeating units. Okay, right then. Mention 5 compounds that are not considered as organic molecules even though it has carbon. Very simple. You write all the carbonates, bicarbonates and oxides of carbon. So, CO2, carbon dioxide. CO, carbon monoxide. Na2CO3, so sodium carbonate. MgCO3, magnesium carbonate. CaCO3, calcium carbonate. All of these things are not considered as, although all of these things are not considered as organic substances, even though these things contain carbon, my dear children. Okay, right. Draw and show the structure of octane molecule. What is the common name given for it? So the common name is petrol. So octane, there are 8 carbon atoms. 8 carbon atoms. 1, 2, 3, 4, 5, 6, 7, 8. All are single bonds. Why do all are single bonds? Because it is showing an N over here. That means it is an alkane. Now, in order to create 4 bonds between each and every carbon atom, complete the cycle or complete the number of bonds by using hydrogen. Okay, remember each and every carbon atom should have 4 bonds. So here we go. 1, 2, 3. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2, 3. Now let's put hydrogen. Hydrogen, 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 hydrogen. Okay. So my dear children, it's very simple. This is octane. Okay. C8, H18. Let's see whether there are 18 hydrogen atoms are there. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 8, 8, 16. That one over here, this one over there. 16 plus 2, 18. So our answer is correct. Right. Then the next one. Write the balanced chemical equation for the combustion of octane. State whether it is exothermic or endothermic with reasons. So, combustion of any fuel is an exothermic reaction because upon combustion, heat energy is released to the environment. Okay. So, first of all, we'll write the chemical equation then. C8, H18, oxygen gas, CO2, H2O. Now let's balance. 8 carbon, 8 to here. Here 18 hydrogen, then 9 to here. So 16, 9, 25 means you have to put here 25 over 2 so that it would cut. Now multiply all the terms by 2. So when you multiply all the terms by 2, my dear children, here it becomes 2, and over there when you multiply this one by 2, 2 to 2 is getting cancelled. That means here it becomes 25, just 25, remember. Okay, so here 25 and here it becomes 16, 8 times 2. 16. Then over here it becomes 9 times 2, 18 H2O. Now let's see whether our equation is correct or wrong. Here carbon 2 times 8, 16. 16 carbon, balanced. Here hydrogen 18 times 2, 36. 18 times 2, 36. Here 25 times 2, 50 oxygen. Here 16 times 2, 30, 16 times 2, 32 plus 18, 50. So our answer is correct. Right. Now state whether this is exothermic or endothermic with reasons. So this is exothermic. Reason is because heat is given out when burning oxygen. When burning oxygen. Not oxygen, when burning. Here we are using octane, right? So when burning octane with oxygen. Right? When burning octane with oxygen. So you know that for the reaction between each and every combustion, okay, oxygen is important. So during the reaction between octane with oxygen, what will happen? Heat energy is released to the environment. So therefore, this is exothermic. Right. Then the next one. So next one, write 5 benefits of using polymers. 5 benefits. Number 1, cheap. Number 2, easy to use. Number 3, long lasting. Number 4, right, can be obtained easily. Can be obtained easily. Then number 5, can be obtained in different shapes, colors. So we can obtain these things with different shapes and with different colors. So therefore, these things are beneficial. So cheap, easy to use, long lasting, can be obtained easily, and can be obtained in different shapes and colors are some benefits of using polymers. Okay. Then the next question. Mention 3 uses of Teflon. 3 uses of Teflon to make cooking pans. Right, to make cooking pans, we can use Teflon, my dear children. Right, so you know that to make cooking pans, especially non-stick cooking pans, we use Teflon, right? Because you know that Teflon is a material which is not getting stick. Okay, materials are not getting stick on Teflon, so we use Teflon to make cooking pans. Then the next one, snowshoes. To make snowshoes. Then, my dear children, to make insulators. To make insulators also we can use Teflon, right? So these are the uses. Next one, combustion of hydrocarbons is not environment friendly. Support above with 2 reasons. Very simple, my dear children. Number 1, it emits CO2 gas. Next one, combustion will emit harmful gases. Combustion will emit harmful gases, and it will emit CO2 gas because of the combustion. Right. Then the next one. Write 5 artificial polymers and 5 natural polymers. 5 artificial polymers, 5 natural polymers. Okay. So DNA, starch, protein, then rubber and carbohydrates. right? Carbohydrates, rubber, protein, starch and DNA. These things are natural. Then my dear children, PVC, then Teflon, polythene, right? PVC, Teflon, polythene, then rigiform, which is also called as styrofoam, my dear children. Okay, then PVC, Teflon, polythene, rigiform and bakelite. So these things are artificial. Okay, these things are artificial. So artificial, PVC, Teflon, polythene, rigiform, bakelite. Natural, DNA, protein, rubber and carbohydrates. Right, next one. Polythene usage has dramatically increased in modern world. Write 3 reasons for it. Why does the polythene usage has been dramatically increased? Mainly because of these reasons. Number 1, the cheapness, right? Cheap. Number 2, easy of use or easy to use. Then number 3, durable. Right? So durability, the ease of use and the cheapness. Because of having these factors, the usage of polythene has been dramatically increased in the modern world, my dear children. Okay, right. Then the next one, question number 11. Mention the monomer used to form natural rubber. Draw and show the structure as well. Right. So monomer used to form natural rubber, it is called as the isoprene molecule. 1, 2, 3, 4, CH3, at the 2 ends double bonds, then all the others are hydrogen. 1, 2, 3, 4 completed. 1, 2, 3, 1 should be there. 1, 2, 2 should be there. So this is isoprene molecule, my dear children. Okay, isoprene. Isoprene. Next one, define each of given terms. Monomer. So monomer means this is the structural unit or else small molecule used to create or used to form polymer, right? Small molecule used to form polymer. Repeating unit, this is the structural unit. Structural unit of the polymer means that repeating units are the ones which are getting collected to each other several times in order to create the polymer, right? So structural unit of the polymer is the repeating unit. Then the next one, polymer. large molecule created by the combination of smaller molecules. Right. So, large molecule created by the combination of combination of smaller molecules. Right. So, monomer is the small molecule used to form polymer. Repeating unit is the structural unit of the polymer. Polymer is the large molecule created by the combination of smaller molecules. Okay. So, monomer, repeating unit and the polymer, my dear children. Right. Then the next question. Okay. So, complete the given table. You have to complete the table given. Teflon, PVC and polythene, repeating unit, monomer and a use. Right. So, Teflon, this is C2F4. PVC, polyvinyl chloride, C2H3Cl. Polythene, C2H4. Right, C2H4. So, mention N as well. We need to mention N as well. So, it's because this is the polymer, my dear children. So, we have to include N as well. So, the repeating unit is like this. Fluorine, 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 fluorine. This is the repeating unit. Teflon. Then the monomer, right? So, monomer means, my dear children, this is the initial molecule before the breakdown of double bonds. So, here C double bond C and 4 fluorine molecules, tetrafluoroethene. Here we go. Then the use to make snowshoes. Used to make snowshoes. Then PVC, my dear children. Repeating unit. Carbon, carbon, then chlorine, hydrogen, 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 then this is the repeating unit. C2H3Cl, okay, C2H3Cl. Then the monomer, the chloroethene, C double bond C, chlorine, hydrogen, hydrogen, hydrogen. Then a use, PVC, used to make water pipes. Used to make water pipes. Then, my dear children, third one, polythene. Repeating unit. C, hydrogen, 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 hydrogen. This is the repeating unit. Okay, C2H4. Then next one, monomer. Monomer is ethene, my dear children. Hydrogen, 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 hydrogen. Then use to make bags. To make bags. Right. So this is the question which is given regarding the repeating unit monomer and the use of the polymers Teflon, PVC and polythene. Right. Then the next question. Question number 14. Identify the given types of polymers and provide an example. Okay, this one, linear polymer. Linear polymer, right? Example, rubber. Next one, this one, polymer with side chains. Examples, some proteins are good examples. Some proteins. Then the third one, polymer with crosslinks. Example, vulcanized rubber. Vulcanized rubber. So this is a linear polymer, my dear children. Rubber is an example. This is a polymer with side chains. Proteins are examples. Polymer with crosslinks, the third one. Vulcanized rubber is the example. Right. Then the next question. Question number 15. Mention 3 drawbacks of using artificial polymers. Number 1. Environment pollution. Environment pollution, right? It will cause environment pollution for sure. Then next one, number 2. Number 2 can cause harm, can cause harms to animal lives. Right? Can cause harms to animal life. Next one, number 3. Combustion will release harmful gases. Right? So my dear children, environment pollution, right, then can cause harms to animal life. Then combustion will release harmful gases, right? So these are the drawbacks of using artificial polymers. Next one. Write 3 remedies used for above drawbacks. Okay. Number 1. Developing polymers which decay due to sunlight. Next one, number 2, mixing with natural polymers. Mixing with natural polymers like cloth, right? Mixing with natural polymers. Then number 3, developing water soluble polymers. Right. So developing polymer which decay due to sunlight, mixing with natural polymers, and developing water soluble polymers are some remedies for the drawbacks, my dear children. Okay. Right. Then the next question. Divide the given compounds into alkane, alkene and alkyne. Mention their names as well. Right. So alkane, alkene and alkyne. So I'll use 3 categories over here. Alkane, alkane, alkene and alkyne. Okay. Right. Alkane, alkene, alkyne. Right. C3H6. So 2N. That means it is an alkene. C3H6. This is referred as 3 carbon atoms. So prop. This is propene. Propene. Okay, propene. Next one, C2H2. It is an alkyne, my dear children, because C2H2 means 2 into 2 minus 2. 2 into 2, 4. 4 minus 2 is 2, right? So it is an alkyne. C2H2. This is ethine. Ethine. Okay. So this one correct, this one correct. Third one, C7H16. 7 times 2, 14. 14 plus 2, 16. So it is an alkane. C7H16. This is called as heptane. Heptane. After hexane, heptane, my dear children. Carbon 7, hydrogen 16, heptane. C5H10. Once again an alkene because 2N. C5H10. So this is pentene. Pentene. Next one, C5H12. So 2N plus 2. Alkane, C5H12. This is pentane. 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 C4H6. So C4H6. 4 times 2, 8 minus 2. That means 6. So it is a alkyne. C4H6. butane, 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 right? Next one, C4H10, 4 times 2, 8, 8 plus 2, 10. So C4H10, C4H10 is butane, butane. Next one, C2H4. This is very simple, my dear children. This is ethene. C2H4, ethene, ethene. Next one, CH4, very simple, methane or methane. Methane, CH4. C8H18, 8 times 2, 16, 16 plus 2, 18. Once again, an alkane. C8H18, this is octane. Next one, C3H8, C3H8. So this is 3 times 2 plus 2. Once again an alkane. So C3H8. So this is propane, right? Propane, propane. Then C4H8, C4H8, which is the final one. C4H8, my dear children, this is, here you can see 2 times as the carbon atoms. Hydrogen atom count is 2 times as the carbon atoms. So C4H8, this is an alkene which goes by the name butene, butene. So C7H16, C5H12, C4H10, CH4, C8H18, C3H8, heptane, pentane, butane, methane, octane and propane, C3H6, C5H10, C2H4, C4H8, propene, pentene, ethene, butene, C2H2, ethine, C4H6, butane, right? So these are the separations of alkane and alkynes, right, according to the given substances. Right, then the next question, draw and show the structural formula. Butene. So but means there are 4, 1, 2, 3, 4. Ene, that means there should be a double bond. And now complete all the others by using single bonds. Right. 1, 2, 3, 4, 5, 6, 7, 8. So C4H8. Our answer is correct. Butene. Next one, pentane. Simple, my dear children. Here we go. 1, 2, 3, 4, 5 single bonds as it is an ane. Then hydrogen, 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 and hydrogen, and another hydrogen. This is pentane. Then hexane. Hex means 6. So 1, 2, 3, 4, 5, 6 all are single bonds. Then, my dear children, the completion of bonds. Right. in order to have 4 bonds among each and every carbon atom, complete the valence bonds by using hydrogen atoms. Hexane. Methane, very simple my dear children, CH4. Here we go, CH4. So this is methane. Then final one, propene. Prop means 3. So 1, 2, 3. In means there should be double bond. Then others are single. Now let's complete. 1, 2, 3. 1, 2, 3. Then 1, 2, 3. Only 1. Then over here again 2. Right. So 1, 2, 3, 4, 5, 6. Propene. So these are the structures for each and every formula given within the board. So the structure or the chemical substance butene, this is the structure. Pentane, this is the structure. Hexane, this is the one. Methane, very simple, this is the one. Then propene, this is the one. Okay, structural formula. Write a use of given polymers. Polyester, simple my dear children, to make cloth. To make cloth. Next one, nylon. Nylon is being used to make ropes. Right, then the next one my dear children, terylene. So terylene is also used to make cloth items. So to make cloth. Next one, polystyrene, to make food packages. Or else food wraps. Next one, bakelite, to make insulators. To make insulators, we use bakelite. So polyester to make cloth, and also terylene to make cloth. Nylon to make ropes, polystyrene to make food wraps, and bakelite to make insulators. Okay, right then. The next one. Explain how vulcanized rubber is formed. Write 2 uses of vulcanized rubber. So by reacting natural rubber with sulfur to create crosslinks. Okay, to create crosslinks. So this is how we are going to create vulcanized rubber. So vulcanized rubber is a good example, right, for the polymers that has crosslinks, right? Then you have to write down 2 uses of vulcanized rubber. 2 uses: to make tires, right, to make tubes and tires, then to make battery cases. So to make tires and tubes and to make battery cases, we use this vulcanized rubber. Right then. The next one. Write 3 users of hydrocarbons. 3 users of hydrocarbons. Very simple, my dear children. To operate machines, we use hydrocarbons as a fuel. So, to operate machines. Then, to operate vehicles. And to generate electricity also, we use hydrocarbons. So these are the users of hydrocarbons. To operate machines, we use hydrocarbons. Then to operate vehicles in engines, we use hydrocarbons. Then to generate electricity also, we use hydrocarbons. Right. Explain how hydrocarbons are produced. Very simple, my dear children. By using fossil fuel. Right. By using fossil fuel. Most of the times by using fossil fuel, we can produce hydrocarbons. So, if you are going to clarify even more, you can write by using fossil fuel through fractional distillation. Right? Through fractional distillation, by using fossil fuel, and through the fractional distillation, we can produce hydrocarbons, my dear children. Right. So we have answered several extra questions related to the lesson hydrocarbons and their derivatives. So my dear children, we have came to the end of our lesson. Right. We have answered every question in your textbook and several extra questions as well, and we have covered each and every theoretical part in your textbook, my dear children, related to the lesson part hydrocarbons and the derivatives. Right. So my dear children, with that one, I'm going to wind up this chapter. So on the next day, we'll start our next lesson, which is the last lesson in your grade 11 science syllabus regarding the biosphere. Right? So till then, it's time to say goodbye.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.